Hi everyone, welcome back to our YouTube channel Sid Education. In our today's video, we are gonna discuss about quick sort algorithm. So let's get started. When I talk about quick sort algorithm, this algorithm works on three fundamentals. The first fundamental is pivot, second fundamental is partition, and third fundamental is recursive call. Let's talk about each of them one by one. So what is pivot? So pivot is nothing but is a special element. I'll write it's a special element. All right, it's a special element around which array is arranged in a manner in a manner. Okay, it's nothing. It's a element of the array itself. For example, I'll just give a uh, example to you. Let's say you have 15, 2, 16, 9, and let's say 17. These are your array elements. Okay. Now you can call any element as pivot element. You can call the first element as pivot. This can be your pivot. You can assume this last element as pivot. You can randomly choose the pivot. For example, you want to choose this as pivot, right? Or you can take a median and choose that as pivot, right? So pivot, what's the use of this pivot? Actually, if you see the name of the algorithm, it says quick sort. Means you need to sort quickly. So what's the fundamental behind quick? The fundamental behind quick is that when you say any element, let's say I'm saying this element as 15. When I say this 15, so as pivot, so this pivot element will figure it out its position in the array. So for example, this is the position 1, 2, 3, 4, 5, 5 elements, right? So this 15 knows where to sit. This 15 knows where to sit. It will quickly arrange its position to its correct position, right? It will quickly arrange its position to its correct position in a sorted array. That is why we choose pivot. Then in next iteration again we'll take another element as pivot and we'll arrange that element to its right position, right? That is why it is called as quick sort. Are you understanding? You have to be with the videos because we're going to start with basics and then in the next videos I'm going to take an example and exactly show you how to trace this algorithm, right? So be with us, right? So pivot is nothing but it's any element and I am telling that pivot can be first element, right? Can be last element, can be random element also, or can be many a times it is a median. Now, there can be a lot of discussion around pivot element, like which one to take, right? I'll suggest you should take random, but in some of the curriculums, we say that the concepts are being taught with the help of last element or the first element, right? So we'll take example on each of the P on this, like taking first pivot element, second pivot element, random pivot element, last pivot element, median pivot element, right? We're going to see the examples, right? The second concept is partition. Now, when I talk about quick sort is also based on divide and conquer. Divide and conquer. So, what is divide and conquer? Well, basically, this is a problem. You divide it into two parts, and then you tackle this to get this done. This is divide and conquer. So, basically, the same fundamental we have is partition. So, what partition basically do? For example, let's take this example 15 2, 16, 9, 17. Okay, so I'll consider this thing, right? First as my pivot element for my examples. Okay, first element as my pivot example. So if I say this is pivot element, so according to quick sort, the 15 will arrange itself to its right position. So we'll see how it does. I'm doing the iteration, okay? So I am just doing it that way. So actually, according to this, 15 should come here, okay? This position, right? And there will be 1, 2, 3, 4. I don't know what will come here and come here. If I'm considering this as pivot, this is the right place. How I got this, we'll see in an example, right? I'm just telling you. We'll trace the algorithm and we'll see. Now you see that all the elements which are coming here to the left of this pivot element are less than 15. And you will see all the elements which are coming to right to 15 are greater than 15. It means that partition, so it act as a partition, means all the elements here are less than and all the elements here are greater than. It means this 15 is at right position, and this fundamentals, this creation is called as partition. So I had created a partition. Now again, now this was the problem. Now this problem is divided into this and this. Now you again put quick sort here, again use quick sort here. That is what recursive. That is nothing but called as recursive call. This is nothing but called as recursive call. So that's why. That's just I was saying it is based on three fundamentals. That is on pivot element. First, you need to select a pivot element. Now, what is pivot element? I told you it's an element which you are going to select, and that element going to correct its position in the array. Then what is partition? Partition is nothing but all the elements left to it will be less than this and right to this will be greater than this. So we'll have a partition, we'll have a subarray, we'll have a subarray. Now again, same, using the same fundamental, you're going to tackle this situation and this situation. Are you understanding? Now again, this partition is also been given some names, okay? So if you say there are something called as nave partition, okay? There is something called as Locuto's partition, and there are all something called as Fourier's partition, right? So you don't have to consider this, you just can think of partition. But if anyone is interested, I can say that in Nave's partition, we create a copy of the array and first put all smaller elements and then all greater elements, right? We create a copy, I can write, we create a copy of array and then we put all the great for smaller elements and then the greater elements, right? And then we copy the temporary array back to the original array, right? In Lomotos, we consider what we consider the tracking indexes, right? We check the indexes and we swap, right? It is also of O of n, right? If you want to discuss more about this, I can have a separate video where we can discuss about these of them. And this Horace partition is the fastest of all. It is the fastest among these two. Here we traverse array from both the sides, right? We'll keep I and j and we'll traverse both the sides. Correct? So we'll see on this, right? So let's take an example and solve this array. I'll take same array for you in the next video and we'll see what this pivot means, what this partition means with this recursive call means. So I'm going to trace these things exactly in our next video. So if you like this video, please do like, share and subscribe. Thank you.